problem, we have a vector. We have its x component and its y component. What is the magnitude of that actual vector? So let's sketch out what's going on. If we have an x component of 7.18 meters, that's a positive. So I'm saying if this is the x component, 7.18 meters, and we want to add to that the y component. So we want to add those vectors, tail to tip here. Y is a little bit less. I'm not using a ruler and drawing these to scale, but AX, a little bit bigger magnitude. And so what we want to know then is, what is the result? Well, the result is that actual vector A. Any vector is the result of adding its x component plus its y component, as long as these are lined up right here, tail to tip. But what this does is, when we draw this diagram or these vectors, we have a 90-degree angle. And as long as we have a 90-degree angle, then we can use the Pythagorean theorem. So A is going to equal ax squared plus ay squared, but we want to take the square root of both sides. In trig or in math, you say something like a squared plus b squared equals c squared, the Pythagorean theorem. Okay, here we're using a, ax, and ay, but c right there is the hypotenuse. So c takes the place of a. It can be a little confusing here. So plug in these values. If ax is 7.18 squared plus 4.72 squared, and we want to take the square root of that. So if I do 7.18 squared plus 4.72 squared, and I'm going to take the square root of that answer, then A itself, that vector itself, has a magnitude of 8.59 meters. We only wanted its magnitude on this one, not its direction as well.